Ready?
Hello there, my name is Edward Matos, and today I will be going over a question to check if it converges. What I will be using, the test that I will be using to test if this converges is the ratio test. So what we have here is Ke, but the E is raised to negative K power, right? But what I will be doing is I will be rewriting it and changing it up so that it will equal the same thing, of course, but I will have it look prettier so I can work with it in the ratio test. So in the ratio test, there are two expressions that you work with. There is the an expression and the an plus 1 expression. The an expression is this one right here that we have seen right here, but I will be rewriting it. So I will have k in the numerator, and I will have e raised to the power of k in the denominator. Now for the an plus 1, I will be writing this as k plus 1 because for this expression you must add 1 to wherever you see k. So, and in denominator I will have e raised to the power of k plus 1. And the 1, it is important that you notice that the 1 is in the exponent area. Now for this we normally do have there's a formula that you need to use in your limits so that you can find if it converges. This is an plus 1 over 1 multiplied by 1 over an. That is the formula. So then what we'll be doing is we'll write this in form of limits. So it'll be limit as k approaches infinity, right? And we will be writing this formula, but we will be substituting already in it. So an plus 1 over 1, that is just k plus 1 over e raised to the power of k plus 1. So that's k plus 1, e raised to the power of k plus 1, multiplied by 1 over, well, not 1 over, but we'll already be reciprocating, so that will be ek over k. So that's that, right? Now what we'll be doing, the next step that we will be doing is that we will change the formatting of this problem specifically right here so that we can cancel out clearly. So we can clearly see that we can cancel out. Alright, so I'll be writing this limit part again. K, it approaches infinity. Keep the numerator the same. And the denominator now, I will be writing e raised to the power of k plus 1 as e to the power of k times e, because that's due to the law of exponents, no? And then I will leave this the same way right here as it is up there. And now we can clearly see that we can start canceling out, right? So we cancel this out, we cancel that out. Clear, we can see that clearly. So what I will be doing now is I will factor out the constant, right? And the constant is e, of course. It will be 1 over e. That's the constant. So I will take that out here. And I have the limit. K approaches infinity. And then I will have k plus 1 over k. So now we have something that looks a bit more prettier. We can now figure out if it converges easily now. If you cannot tell that this will become 1, this will become 1, I will be showing it. So an easy way that I figure out how to see is that I will be dividing each thing in here by k. So that would be k divided by k plus 1 divided by k and k divided by k. Now right here you can see that this becomes 1, this becomes 1, and this becomes 0. So I will rewrite this right now as 1. Rewrite this now as 1, and this becomes 0, and this 1 over e times 1 is just 1 over e, and we know that 1 over e is less than 1, so that means that it converges. So that is the ratio test. Thank you for your attention. Also, thank you for bearing with me. My markers aren't working well. And I hope that you could understand how I did this.